Let's talk about 7.6. Inverse 7.6 is inverse trig functions. Maybe I should have capitalized the inverse because that's kind of that's the main thing. We have studied inverse functions before, but let's talk about inverse trig functions today. So a quick little review on inverse functions that we know a little bit about these things. If I were to graph kind of the favorite that we seem to graph a lot of the time, so if I give you f of x equals x squared, and if I plotted a couple points on here, this is a good one to plot because when x is 2, y is 4, we could do 1, 1, etc. If we wanted to sketch the inverse, remember what we did? We just switched our x's and y's around. Now, before I get too carried away, why does this function not have an inverse? Maybe before I ask that question, tell me why is this a function? Passes a vertical line test. It is a function because it passes a vertical line test. Every value of x, there's one value of y. You don't have a person with two different birthdays, so it passes a vertical line test. But for it to have an inverse, we have a stronger restriction, and what is that? Vertical line test and the horizontal line test. And the word we say then is the function has to be one, two, one. If it passes a vertical line test and horizontal line test, the function is 1 to 1, and it has to be 1 to 1 in order for it to have an inverse. So this function right here would not have an inverse because for this value of y, we also have a value of x, and that's negative 2, 4. So it would not have an inverse if I included the back side. If I took this part off, it would have an inverse because it would pass the vertical line test, it would pass the horizontal line test. And how we graph that is we just change our ordered pairs around. So we'd have 0, 0 still, 1, 1 still, but instead of 2, 4, we'd be out here at 4, 2. So the thing looks something like this. That is the inverse, and we identify the inverse like that, F inverse. Remember, the inverse of the function is not equal to the reciprocal of the function to the positive first. That is not true. We've done some work with negative exponents. I just want you to understand that that does not mean a negative 1 for an exponent. You can do that, but usually it's in parentheses raised to a negative 1 power. This notation means the inverse. And does anybody know the equation of that inverse? How do you undo squaring something? You square root something. So the inverse is the square root of x. And of course, we would need to state this for x greater than or equal to 0. It's not true. You can't do the square root of a negative number and get a real answer. You can get an imaginary answer. So has to pass the horizontal line test in addition to the vertical line test in general when we talk about functions. So let's jump in and talk about trig functions. And the one I'd like to start with is the tangent. And it's maybe the hardest for us to visualize. Well, I don't know hardest, but it's harder, I think, than the sine and cosine. We know that we have a vertical asymptote at pi over 2. We'd have another one at 3 pi over 2. We'd have another one at 5 pi over 2. We'd have one over here at negative pi over 2. And we can keep going. And the shape of the tangent looks something like this. So that's quadrant 1. In quadrant 1, it's positive. And over here, this is quadrant 4. And in quadrant 4, it's negative. This is quadrant 4. This is quadrant 1. We're going to have a 0 right here. In quadrant 3, it's positive. In quadrant 2, it's negative. And we can continue to do this. And when I do that, we can see that that right there passes the vertical line test. It's a function. But the way I've sketched the tangent, it does not have an inverse because it would not pass the horizontal line test. So what we do so that it will have an inverse is we restrict the domain. We are going to restrict the domain, and we're going to restrict the domain, and I'll graph this again on the next page, but we're going to restrict the domain from negative pi over 2 to pi over 2. That will give us all of the values that we need. So let me just go to the next page and sketch, well, do that. But right here and right here, so there is my tangent restricted from negative pi over 2 to pi over 2. In other words, it takes on all of the values from negative 90 degrees to 90 degrees. And what it would look like would be something like this. This would be the inverse. And we identify the inverse like that. That is the inverse tangent. Some people say arc tangent. So if you ever see y equals arc tangent of x and y equals the inverse tangent of x, these two things mean the same thing. Arc tangent, you might see that on the ACT test or a tri-college math contest. You might see the arc in front of it. All it means is the inverse tangent. Our textbook writes it this way, and I just don't put a capital T on it. I don't know why you have to, but I usually do things the way my math teachers did, and they didn't. So when I say teachers in high school, teachers in college, so I just say the inverse tangent like the middle one. But they all mean the same thing. It's the inverse tangent. So if I were to plot a couple points on this one, we know we have this point right here at 45 degrees, it's 1. But as I get closer and closer to 90 degrees, of course, it takes off because the denominator gets closer and closer to 0. Because tangent is the sine over the cosine. And as we get closer to 90 degrees, the denominator gets really, really small because cosine gets closer to 0. So then this thing gets really, really big. Likewise, here at negative 45 degrees, it's negative 1, and we could go this way. So if I plot them, all I do is switch my points around. So then this right here would approach pi over 2, and this would approach negative pi over 2. And this becomes a horizontal tangent instead of a vertical tangent. This is a horizontal tangent. Now, what good does all of this do? I think that's a fair question. Why do I care about this? The bottom line is we want to be able to go backwards. We want to be able to find out the angle if I tell you the tangent. That's the only reason. So don't get stressed about looking at the graphs of these things. I do that because I think it's important to know that it has to pass the horizontal line test, has to be 1-to-1, so we only look at this piece. We only look at negative 90 degrees to 90 degrees. In other words, we only look at quadrant 4 and quadrant 1, because in quadrant 4 the tangent's negative, quadrant 1 the tangent's positive. That gives us all of the values that we need. So you might be asked to do something like this. The tangent of theta is the square root of 3. Maybe before I do that, let's just do something here really quick. The sine of theta, the cosine of theta, and we have this table that we've already done. So here's my theta. We'll say 0, 30 degrees, 45, 60, and 90. I think this is worth our time to do for these two. Just to quickly review, I know it was just on the quiz we just did. But it will help us get the tangent. So the sine of 0 is 0, sine of 30 is a half, this one's square root of 2 over 2, this one's square root of 3 over 2, and this one's 1. And the cosine at 0 is 1, and we found out that one's root 3 over 2, that one is the same. And we're thinking how we got these was 30, 60, 90 triangles and 45, 45, 90 triangles. I screwed something up. Sorry, this should be 1 and that should be 0. Now the reason I do that, and I don't think you have to memorize this, but I think it's good to know the tangent. Let's add the tangent to our graph, to our table. I think this is beneficial for all of the nice angles. And if we know the nice angles in quadrant 1, then we'll know what the nice angles are in quadrants 2, 3, and 4 because of reference angles. And then you have to decide if it's positive or negative and all that good stuff. So the tangent is sine over cosine. So it's this number divided by this number. So the tangent at 0 is 0. Let's do the other one that's easy. and that's over here at 90 degrees. The tangent at 90 degrees, 1 divided by 0 is undefined. You can't do it. That's why on our graph we have a vertical asymptote at 90 degrees, pi over 2 radians. The other one that's really easy to do is 45. Because the square root of 2 divided by 2 divided by itself, anything divided by itself is 1. The other two are a little bit harder. If I did this one, I have 1/2 divided by root 3 over 2. I'm finding that more and more students in your generation, and don't take this the wrong way, really don't like fractions. Because we've plugged them into our calculators our whole lives, and we really don't understand them. And I don't really say that to you because you're in pre-calculus. You're good students. But on the whole, if I were to survey kids in Kennedy, I would find a lot of students would really struggle with that problem because they don't understand the simple idea of multiplying by the reciprocal. So you multiply by the reciprocal, and you could, depending on where you're at, you could take this number and know that the denominator becomes the numerator. But let's not try to memorize stuff. Just multiply by the reciprocal, so you get 2 over square root 3. You have the 2 on the top and the 2 on the bottom. They divide to 1. You get 1 divided by the square root of 3. We don't like that in high school mathematics. College mathematics, we don't really care. But in high school mathematics, we say we have to rationalize our denominator. What's 1 divided by the square root of 3? The square root of 3 divided by 3. That's a nice one. But you don't have to memorize it because you can always figure it out from your sine and your cosine. The other one that's a little bit tricky is this one at 60 degrees, or pi over 3. So you have root 3 over 2 divided by 1/2. Well, that means root 3 over 2 multiplied by the reciprocal 2 over 1. 2's divide to 1, and you end up with, instead of 1 divided by root 3, you get root 3 divided by 1. So, back to, I think that's beneficial to add that to your table. Let's go back to this question then. I'm asking, where is the tangent the square root of 3? Big picture, here's the inverse. Yeah, we want to undo these things. Just like back in the day when you were youngsters, you did 5x equals 20, and you wanted to know what x was. Before you did that one, though, you probably did x plus 5 equals 7. Don't you wish you could go back? How did you undo x plus 5 equals 7? How did you get x by itself? You did the inverse operation of adding, which is subtracting. That's the inverse operation. You add the opposite. On the second one, the inverse operation of multiplying is dividing. You undo that. And then you graduated to doing things like x squared equals 4, and you had to undo squaring. The inverse operation of squaring is square rooting. We could do cubing and cube rooting, etc. But it's the inverse operation. So how should we solve for theta? How do you undo the tangent? Now, back to our notation from earlier, f of f inverse of anything is that thing, so that star, and the inverse of the function of something is also going to take you back to where you started. So what I would want to do on a problem like this is I would like to do the inverse tangent of the tangent. The inverse tangent of the tangent is exactly this notation right here. I guess the second one, because we're doing the inverse of the function. So this gives me theta. But we know if we do something to the left, we have to do it to the right. So we would do the inverse tangent of the right side. So it says it's inverse tangent of the square root of 3. So if I were to jump back to this, if this is 1, I'm looking at the square root of 3 being about right here. I'm trying to find out what's the angle that gives me the square root of 3. Our calculators will do this for us. This is also a nice one. We know that the square root of 3 is right here. So I know that my angle has to be 60 degrees. So theta is 60 degrees. Or we would say pi over 3. If you do it on your calculator, let's try a couple of these. How come I can't see it? I have a lighting problem. Sorry. I didn't before you guys walked in, but I'm supposed to shut that light off. So if I do invert, I better see what a mode I'm in, first of all. I'm in degrees. So I say, what's the inverse tangent? So it's above the tangent. There's the inverse tangent of the square root of 3. My calculator is going to tell me it's 60. If instead I was in radians, if I do this again, but I change this to radians, and I do that, and it says it's 1.05. We don't want to write down 1.05. We need to know that that is the same as pi divided by 3. You need to write down pi over 3 because it's one that's nice. So we kind of got to recognize some that are nice. Now, a lot of them we'll do on our calculator, they are not nice. So let's just do a couple for the fun of it. If I did inverse tangent of 5, can I do the inverse tangent to 5? The answer is sure. I'm in radians right now. If you don't want to be in radians, if it helps you to think degrees, I think most of us it kind of does. It's at 79 degrees. If I do the tangent of 78.7 degrees, do I get 5? They go back and forth because they're inverse functions. Can I do the inverse tangent of 18? Is that possible? The answer is yeah. We just get closer to 90 degrees. That's all. We just keep getting closer and closer to 90 degrees. If I tried this, now we haven't looked at these next ones, but what if I did try to do the inverse sine of 18? What's my calculator going to tell me? Hey, idiot, you can't do that. At least if you have a Texas Instruments, that's what it's going to say. Well, they used to say that till they got sued. And they made people's self-esteem go down. Now it says domain error, so you can't do that. But it should say, hey, you can't do that. How come? Why can't you do that? Well, let's look at the tangent function here really quick, or not tangent, sorry. Let's look at the sine function really quick. What's the sine of theta look like? If that's theta, well, we know that the sine of theta looks something like that. One period of it anyway. And we could continue it over here. We could continue it over here. It only goes up to 1. It only goes down to -1. It's impossible to do the sine of an angle and get 18. Your answers will always be between 1 and -1. Make sense? Now, if I wanted to restrict this one so that it is 1 to 1, on the tangent, we went negative pi over 2 to pi over 2. Where should I restrict the sine function so that it's 1 to 1? Where should I restrict this one?
Good morning. We just want to make a couple of announcements for seniors. Want to remind seniors that your senior T-shirts do need to be paid for by the end of the day Monday. So please stop down to the high school office and make sure you take care of that as soon as possible. Also, this is a message for all seniors. We do need to vote on class motto, class flower, class colors, class song. Those ballots, we will not pull you out of class to vote. It is up to you to come to the office and vote sometime between now and tomorrow before the Snow Olympics or during the Snow Olympics. We will have all those ballots available in the high school office. So seniors,
don't get excited. Don't get bent out of shape if you don't get your pick, because nobody cares. Just make sure it's not too long.
Senior class colors, motto, song, and flower.
Shouldn't your colors be maroon and gold? Aren't we maroon and gold? I'm going to get in trouble, probably. But it really doesn't matter, because no one cares, and no one remembers. I laugh. Every school I've been in, every year, the seniors, they get all, I want this, I want this. Who cares? Just say yes. It doesn't. Okay. So we go negative 90 to 90, huh? That gives you all of your answers. That gives you all of your answers. Now, back to our calculator. This is where it gets this gets a little bit messy. If I say, let's quit this here a second. But if I say inverse sine of 0.5, I expect 30 degrees. Nod if you agree with me, right? So sine of 30 is 0.5. If I say inverse sine of 0.8660, I get almost 60 degrees. The sine of 60 is the square root of 3 over 2, and that's 0.8660. If I did 0.707, that's root 2 over 2. So if I did 0.707, should say about 45. Almost. Yeah. And we could do other ones. We can get closer to 1. We can say, what's the inverse sine of 0.9? And it's 64 degrees. But once I get to 1, if I say inverse sine of 1, it tells me it's 90 degrees. So there's a lot of angles that give you a value between 0.9 and 1, in other words. So if I say, what's the inverse sine of 0.95? Of course, it's closer to 90 than it was 64, because we're moving up. But where it gets tricky is when we do this. I'm going to want you to give me all of the answers between 0 and 360. So let's go back and do the 1.5. So that's 30. What are the other answers that have the sign of 0.5? The answers I want you to give me are between 0 and 360. You need to give me one more. And what quadrant is the sign positive in? Quadrant 2. So if 30 degrees is an answer, what's another answer? 150. You need to give me 2 answers. And if you don't believe, do the sine of 150 and you get the same thing as the sine of 30. Where it gets tricky is this. That's really not the tricky part. Where it gets tricky is when I say this. What's the inverse sine? Well, we'll just go the same number, except let's put a negative sign in the front of it. My calculator says negative 30. And that makes sense. It says negative 30 because it's negative 90 to 90. Negative 90 to 90 is your domain on your inverse trig, on your inverse sine. But we don't want to give that for an answer because I want all of the answers 0 to 360. That tells you the reference angle. So what would it be in quadrant 4 if it's negative 30? 330. Where else is the sign negative? Quadrant 3. What is the angle in quadrant 3 that references to 30? 210. So your 2 answers you would tell me would be 210 and 330. So if I do the sine of 210, works. If I do the sine of 330, it works. Now we picked a nice one on purpose. Let's just make sure you're listening. So let's do something like the sine of negative 0.8. The answer is 53 degrees. Negative 53.1. Let's just say negative 53. What are the 2 angles between 0 and 360? You do 360 minus 53. What's that? 307? And you do 180 plus 53. That's why reference angles are so darn important that you understand. 180 plus 53 is 233. Okay? So make sure you give your answers. Now, that's in degrees. I think that's easier. What if we were in radians? Can you visualize what you have to do in radians? Pi is 3.14. 2 pi is 6.28. But you'd probably use pi plus something or 2 pi minus something to get the answers in their respective quadrants. Same thing holds true for tangent. If I say the inverse tangent of negative 0.2, it's a negative 11 degrees. If they say, give me the answers between 0 and 360, you can't say negative 11. What can you say? Well, what's 360 minus 11? We'll just say with 11 because it's easier. 360 minus 11 is 349. What other quadrant is the tangent negative in? 2. That's your reference angle. What is the angle in quadrant 2 that references to 11? 169. So if I did the tangent, remember I've got 0.2 up here. If I do the tangent of 169, and if I do the tangent of 349, are we getting what we thought we would get? Remember, we rounded off a little bit, but that's close to negative 0.2. Okay? So your tangent and your sine, you might get an answer that's negative because it's all the values, and in quadrant 4 you get your negatives, in quadrant 1 you get your positives. Okay? I'm not actually going to make a sketch of it, but that's why we go negative 90 to 90 or negative pi over 2 to pi over 2 because we make it 1 to 1. Let's do the last one, and the last one is the cosine. There's your cosine curve. Where should I restrict that one so that it's 1 to 1? The answer is not negative 90 to 90. Do we see why it's not negative 90 to 90? If I went negative 90 to 90, I'd be going from right here to right here. No good. So instead, where should I go? I'm going to start at 0. I'm going to start at 0, and I'm going to go to 180. This region right here. So what quadrants will your answers always be in? Quadrant 1 and quadrant 2. Quadrant 1 and quadrant 2, because it's positive in quadrant 1, it's negative in quadrant 2. This makes you think a little bit as well. So if I give you, let's go back to our calculators. If I give you, let's do the inverse cosine, and we're still in degrees. Let's do the inverse cosine of 0.3. It's 72.5 degrees. Can you tell me what other quadrant, 0 to 360, where else would I get an answer? And what would that answer be? Where else is the cosine positive? Quadrant 1 and quadrant 4. 72 is your reference angle, so what is it in quadrant 4? 360 minus 72.5, yeah? How much is that? Anybody have it? 2 what? 287.5? 287.5. So if I do the cosine of 287.5, do I get about 0.3? Yeah. Now that's not so bad, getting those two angles, but this gets kind of weird when it's negative. So if I say the inverse cosine of negative 0.5, I'm going to get an answer that's in quadrant 2. It's 120 degrees. That's one of my answers. Where else is the cosine negative? Quadrant 3. You have to do a little thinking in your head to get the reference angle. 120 degrees, I gave a nice one on purpose. What is it reference to? 60. So what angle in quadrant 3 references to 60? 240. 180 plus 60. So if I do the cosine of 240, my calculator is going to say negative 0.5. So when you use cosine, you're going to get an answer that could be obtuse. An angle that could be obtuse. You got to think about what the reference angle is. It doesn't just tell you like when you do the sine or the tangent. Is this making sense? Most of the time, you're going to have to give an answer between 0 and 2 pi or 0 and 360. Let's see if I can find something specific. Every now and then they might not say restricted, but usually they say restricted. And when they say restricted, that's actually kind of a good thing. Let's a lot of these are calculator. There's a good thing that I will kind of start up the next time we have class with to review this. I don't think I'm going to do it right now. I'm going to let you mess with it a little bit. Here's what I'd like you to work on. Page 289, this is the last section. 1 through 4. And I'm going to jump around a little bit here. 5, 7, 9. Probably a better way to write this than what I'm doing, but 11, 12, 13. And I think I had 15, 16, 19, 21, and I'm going to cross those out and not have you do those. 25 and 26. But because I crossed those 4 out, if you look online, I've got 4 extra ones that you do not have to do. So you don't have to do 15, 16, 19, and 21. But I think we should look maybe, is that on the same page? We should maybe look at the class exercises. Might be a good way to start to kind of get your mindset to do that, especially tomorrow when I'm not there. The class exercises, there's like 8 of them, 1 through 8. We don't always do the class exercises. Sometimes I do them with you. I skipped some of the...
So 1 through 4 and 5, 7 are class exercises?
No.
Oh.
I don't know why I drew that in there. But if you look online, it did say 15, 16, 19, and 21, and I'm saying we don't have to do those. I didn't graph. You know, if you look in the book, and you might want to look through, I didn't spend as much time this time teaching this, drawing what the inverse would look like. Instead, we just talked through it and we applied it more this year or today. I hope that's okay, because sometimes I think we can get too bogged down in trying to graph them. And I did the graph here, and not that the graphs are hard, but I would encourage you to look back to the previous page and just see what the graph would look like of the inverse trig function. I think that would be worth your time. This one has asymptotes, so it goes on forever. But when you do the inverse of this one, it does not. It has endpoints. But all you're doing is flipping your x and y around. I just skipped that because I want you to understand. Make sure you understand how to do it. We got a little bit of time. Let's try to plug some of them in, either in our calculator or if they're special, nice ones. Let's just see if we can get some answers kind of quickly. Again, think about where they want your answers to be given. If it doesn't say 0 to 360, then you can just give the answer in one of the quadrants. You don't have to give all of the answers. You just give one answer.